Hello everyone. In this video we're going to talk about the multivariate random variables. So in our current topic we are talking about more than one variable, or what we call the multivariate random variables, and their distribution, which we call joint distribution. So what if we want to study the relationship between two variables x1 and x2, or x and y, or any other names? We have to tell Stata two important things. We have to create a matrix, you can call it any name, I call it sigma here, that includes the variance and covariance between these two variables. So the first one is, let's say if I call x and y, so this is going to be the variance of x and itself, the covariance of x with y, and then the second row is going to be the covariance between y and x and the variance of y and itself. Okay, or in other words, if you mention this is a covariance of x and itself, which is simply the variance of x, and this is the covariance of y in itself, which is simply the variance of y. We need also to tell Stata the matrix or the vector that includes the means. So this is the mean of x and this is the mean of y, or the average of x2 and the average of y3. And remember, we're just making up any numbers. We're just telling Stata, create for me random variables that do have this specific statistics. Okay, so create random variables with these specific statistics. Okay, and again, to make sure that you understand this is a name that you choose. Okay, you can call it any other name, but usually we call it sigma, which is the variance covariance matrix. You can call this one means or M. Okay, so this is up to you. And then the command to create or to draw random variables is called draw norm, and then you give here the names of the variables that you choose. You can call it x1, x2. I decided to call x and y. Tell Stata how many observations you need to draw. I decided to have as 2000, but you can make it bigger or smaller, whatever you like. Telling Stata use the vector m that I have just created here as the means. Telling Stata use the matrix sigma as my variance covariance matrix between x and y. Let's start running this. Okay, and let's try to see some statistics. So CORR is the correlation between x and y. So you tell Stata to what is the correlation. Of course, the correlation between any variable and itself is 1. The correlation between y and itself is 1. But this one is the correlation between x and y. Okay, which is positive, and as x increases by 1%, y would increase by 51.36%, or the opposite, if y increased by 1, x increases by 51.36. So it's positive with this specific magnitude. Again, the correlation, as you remember, is between -1 and 1. Okay, and then if it is 0, then they do not covary. They are basically independent. The next thing is we want to compute the covariance. The covariance is exactly has the same command, which is correlation x and 1, but then comma COV, then this one would give you the covariance between x and y. And this one is telling us that the covariance of x and itself, which is the variance of x, is this number. And remember, when you take the square root of this number, you get the standard deviation of x. The covariance of y in itself is 1.04337. You can also always approximate this number. For example, 1.04. And its square root would give you the standard deviation of y. And this one is the covariance between x and y. Again, positive. And equal to 51. I can always approximate it to 51.83 to the second decimal. Okay, we can also check the statistics, so you can do like a summary of the statistics of these two variables. Again, we have already created 2000 observations, so this is like what we have decided, which is the number of observations. The mean, which is similar to, well, if you approximate this, you would get as 2, okay, which we have decided. Remember, we have it right here. We decided that its mean is 2 and the y mean is 3. So if you approximate this, you get 3, which we have kind of built into this code. Standard deviation of x, right? So you basically get the square root of this number and the standard deviation of y. And then x varies from a negative to positive. It's a normal variable, so it varies from a negative to positive number with a minimum this and maximum this number, and the same thing for y. If you want to see how x looks like, we can do the histogram. It looks normal, centered, as you can see, at 2, where 2 is the average. This is not a standard normal, because the standard normal would have a center at 0, right? So this is not a standard normal. This is just a normal random variable. And y, which has kind of the peak or the midpoint, is around 3. Again, it's a normal, not a standard normal. Standard normal would have the center at 0, okay, which is here. All right, so I'm going to stop here and I'll give you a question very similar to this code to answer.